Good evening, and welcome to the first part of tonight's lecture series about Flutter, hosted here at Lumen. I'm going to talk about Flutter Concurrency, which is a fancy word for parallelism, running things at the same time. A little bit about myself. My name is Moshe. I'm a senior Android consultant at Tikal, programming mostly in Android and Flutter. Personally, I like to run programs. I've been a programmer since my bar mitzvah. The last 16 years, I've primarily been involved with developing for mobile devices, and the last few years also Flutter. And I work at Tikal. Tikal is a company where I can both develop at clients and develop myself. At Tikal, we have various technology groups. We have front-end, back-end, DevOps, ML, and mobile. And obviously, I'm a member of the mobile group. And we learn from each other at weekly meetups and at monthly meetups as well, where we do hands-on coding. So a little bit about tonight's topic. I'm going to explain some problem, something that I personally experienced while developing an app for Flutter. Then I'll present some solutions. Maybe you know them, you don't. And then at the end, can have some questions. All right, so about 20 years ago, I made a desktop app called Electric Fields. It was initially developed in Delphi for Windows, if anybody remembers that. It was supposed to be a simple app, just looks nice, simulating electrical charges in a field. It's interactive. The user can click the screen to manipulate electric charges, add them, invert them, change the magnitude. And the spin was that each image would progressively render more and more little rectangles till you get the final resolution of each pixel. And it gives the user a feeling that something is happening. It's like a fancy progress animation, because also it's a lot of computation. So while it's rendering, at least the user can experience something. A few years ago, I ported it to Android using async task. Shortly afterwards, I migrated it to use RX. A while ago, I ported the app to Flutter, and I experienced some challenges. For example, Flutter doesn't really support mutable bitmaps, which I needed to keep the state of what I've already painted. Flutter doesn't support multi-threading, because I wanted to do the computations and the rendering in the background and update the screen when it's ready. And aside from the no bitmap problem, I want to firstly describe some concurrency so we can better understand what are the issues, what's the problem with Flutter. And when I mean Flutter, I also mean Dot. I'm using them interchangeably, but Flutter is the UI part that we program, and Dot is sort of the lower level. All right, so what's concurrency? Concurrency, like I said at the beginning, it's something that we want to run in parallel. We want to do two things at the same time, two or more things. But the problems that we run into are synchronization issues. There's race conditions, where an app might be running, say, two or more threads that mutate some variable, some resource at the same time. We also face deadlock, where say, multiple threads are waiting for some resource that the other thread has already, and it's not going to release it until it gets what it needs. Dot mostly tries to avoid some of these issues with single-threadedness. It's by design single-threaded, sort of to mimic the experience that users have when they're running in a web browser. Unfortunately, synchronization issues are still possible, even though it's single-threaded, and jank is still likely. Flutter uses Dot, but Dot can run independently of Flutter. So when I'm showing some examples, you can run them, say, in a Dot sandbox. Who are the main culprits? Especially when the data size is large, when reading, writing files, I'm sure we've all experienced this, reading some data from the server, sending some data to the server, you get latencies, you get network failures, just the I/O itself takes a long time. And even database queries, whether it's locally on files or over the network, it also all takes time, and we don't want to stall the CPU, and especially not the user experience. Some more culprits in terms of computations. When we're rendering frames, let's say, the animations happen on the main thread. Rendering frames also happens on the main thread. If we're doing a game that does ray tracing, even the things that happen on the GPU, there's a lot of computations that's happening on the CPU, and we don't want to stall the main thread. When I mean main thread, I also mean the UI thread. Also audio-video decoding or encoding, very expensive computationally. And my app falls into this category of computations because it does a lot of calculations. Like when you see examples that's doing Fibonacci numbers and things like that, it's rather to do it not on the main thread. So here's an example that I brought from Android. Many of us might be familiar with it. If you run this code, let's say in an activity or a fragment, and you wanted to fetch something from the network when the app or the fragment is loaded, and you want to show it to the user. So what would happen? Boom, trach. Network on main thread exception. Android is hinting that you need to use some other way of performing your network request. Nowadays, when we use third-party libraries, such as Retrofit and OKHTTP and all these things, it sort of knows itself that it should not use the main thread, but it's best not to do things like network on main thread or read from databases. Room itself also tells you not to run on the main thread. And if we were doing the same example, say in Dart, if we ran this code in a command line, the user wouldn't really feel anything because there's no really UI that the user would see anything, any delay. This code is perfectly it's perfectly safe to run, say, on a server. But if you ran it in Flutter, the user would feel unresponsive app, especially if the network response is significant or there's some latencies, and the user would experience jank. Let's look at some more of the popular languages that we might be familiar with as mobile developers. In JavaScript, which is single-threaded, there's promises and web workers. Even though JavaScript itself is single-threaded, which means that it's not really multi-threaded, you just get it's simulated. But Java was designed to be concurrent because it was supposed to be implemented for servers, for web servers, distributed. And they have built-in classes for threading, the thread class. There's executors. These are classes that we're all familiar with as Android developers as well. There's the synchronized keyword. When you add that to the signature of a function, it tries to limit the number of entries into that function, but it adds expense. It's a heavy operation relatively. There's a lot of Java classes that are deprecated because of synchronized, like a vector and a string builder or string buffer. And another option is to use RxJava, where it's a third-party library where you can run things on a separate thread, where you specify, I want to produce items on the I/O executor or thread, and I want to maybe produce it as a computation. Well, those of us who know Android, async task has been very popular, but unfortunately they've deprecated it. Maybe people have been abusing it or something. When I was making my app, I was using async task to do the calculations in the background and then to publish updates on the UI thread. That's built into async task. Loader, also when you're loading your app or your fragment, you would use, let's say, a cursor loader to not stall the UI while you're loading things from the database. Handler is still used. Most of the things that happen in handler are on the main thread. You send messages and then you try and process them as quickly as possible. And if you do happen to run something, say, on a side thread, and you want to update the UI, there's the options of run on UI thread. If you have your activity, you pass it, say, some runnable, and post on a view as well. You pass it some runnable, and it will run it on the main thread. Also, if you're using the RX Android third-party library, you have the option of observing what you've produced from the I/O thread or the computation thread, and you can run it on the main thread without causing problem, because all the updates to the UI have to happen on the UI thread. And the service is a component that will run in the same process by default. And it also runs on the main thread, even though there's no UI. So if you have too many things happening in your services, you're also likely to stall your app. Coming to a more familiar or newer languages, we have Kotlin, iOS. There's a suspend keyword. The suspend keyword just means that the function is likely to be blocking. It doesn't mean that it's automatically thread safe and will run separately and not interfere with the main thread. Kotlin also brings with it coroutines, which is also more or less similar to threading, but it's not exactly, because it still runs on the same thread, and they're cooperative, meaning that they switch the timing between each. They let each other to run on the same thread when they need to. In iOS also you have threads, you have a Grand Central Dispatch, and operation queues. So to our familiar dot is single-threaded by design, like I said before. The async keyword means that the function also is potentially blocking, so the event loop can process other events. I'll talk about just now what is an event loop. A function that is marked with the async keyword has to return a future. An async star means that it has to return a stream, and a stream is just like a list of futures. It means that you expect many results. The await keyword will wait for a future to complete, and yield notifies the caller of the stream that a result has been produced. So a future produces one result, a stream produces potentially many results, and you yield those results to whoever was waiting for that stream. We also have isolate, which will be the main bulk of the talk, and we also have RX Dart. Can these features help improve an app's performance? We certainly hope so. Let's first look under the hood how Dart manages these features. Like I said before, Dart uses an event loop. It processes code on its main thread, on its single thread, and it uses an event queue. Flutter, because it's a UI, it wants to repaint many times, so it has many repaint events, and it tries to update the UI at 60 frames per second. So if we have at the head of the queue a repaint, the event loop will take the event, remove the event from the head of the queue, and add it to its microtask queue. In Flutter, the painting is done by building a tree of widgets, which I'm sure we're all familiar with, and it renders them to the screen using the Skia library. So once it's finished with the event, it removes it. What is the next event? We have a tap handler, and we hope that the tap handler code does not take too long, so that it's not too time intensive, even though we would say mark it with async or something. removes the event. Next event, want to repaint again, repaint again. And now let's go back to a synchronous example of Dart. Again, this is a pure Dart that is happy to run also in Flutter, but it also can happen in a Dart VM, say, on a server. We read some file synchronously, and we want to pass it into JSON and do something with it. Can we make this synchronous code asynchronous? We can use the async and await keywords. How do the await keywords affect the concurrency? Changes the way the event loop handles the code. So let's say we get to our read file async. It was here. We have the read file async is marked with async, and it must return a future. And the read file async gets an await, which means that the file data will wait. It won't carry on because it's a future. Future means that it can carry on processing, but the await means don't carry on. I'm waiting for the result. I'm waiting for the string. So when the event looper reaches the await instruction, it can handle other events while waiting for the result. So it's going inside the function read file async. Inside, it sees there's an await, and it can put it back at put the instruction at the back of the queue and carry on processing other events. Do some more repainting. Flutter loves to repaint. The last event will then read from the file, even though it might be a very big file, and return its contents. But this all happens on the main event, on the main thread. So now that we know how the core of an isolate works, what is an isolate? An isolate is something by itself. It's something that's really alone, like when someone has to isolate themselves, say, in quarantine, that we've all experienced. The life cycle of an isolate is very simple. It has some function as an entry point, runs the code, the event looper processes events, and at some point it exits, possibly returning some result. The main isolate has its main function as an entry point. So all those examples I showed you before with the void main, Dart knows that that's the main entry point. That's the code that it needs to run in the main isolate. So can we create other isolates by spawning them? The isolate will run its own code, not related to the main isolate. So if we have a main isolate, it runs by itself, can potentially spawn some new isolate, and it will run its own code, not necessarily the main method. Okay, a little bit more about isolates. Isolates are like threads or processes, but each isolate has its own memory and a single thread running an event loop. It's similar to an Android intent service, where the intent service knows nothing about any activities or fragments or anything, and the only way to talk to it is to send intents. Each isolate has its own memory heap, ensuring that none of the state in an isolate is accessible from any other isolate. That's the main reason why they called it isolates. And because there's no shared memory, you don't have to worry too much about mutexes or locks. It doesn't mean not that you don't need to use them, it just means that you use them much less. And you might need to use a mutex if you do have some critical code. It's not hard to think of some examples where you might mark, say, some functions as async, and then you expect them to run in parallel, but they really will change some mutable variable that's very important. Isolates in the same group share the same code, which is helpful in my app. As each isolate runs in a separate thread, garbage collection events for each isolate really shouldn't impact the other isolates. So if I have my main thread and while I'm building widgets and destroying widgets, the garbage collector will clean up those widgets. It shouldn't affect the isolate that I'm painting my images, and the other way as well. When I'm rendering images and it needs to clean up byte buffers and things like that, it shouldn't interfere with what's going on in the main thread. So how do isolates now talk to each other? Because we have a main isolate and a spawned isolate, and I want to tell it what to do and to get some results back, some images. So isolates talk using ports. Send ports are retrieved from receive ports, and any message sent through a send port is delivered to its corresponding receive port. And they're unidirectional, meaning a send port is only used to send, receive port is only for receiving, and they can only send simple objects, meaning strings, integers, what we would otherwise call POJOs. A message that's sent through its send port is delivered to its corresponding receive port, where it was created from, and the message is dispatched to receive port's listener. It's not broadcast, it's only one listener receives one result. And the receive port is a non-broadcasting, which is okay because we only have one isolate that is listening. And from experience, you can't send functions as parameters to the isolate, and you can't send callbacks to, say, receive a byte buffer or even a byte. You can't pass code. So if we now have an isolate.spawn, we spawn the isolate, and we pass it some initial argument, which says, when you happen to run this code, here's how I want you to behave. The initial request is the function argument when it's created, and you don't have to pass an initial request. A spawned isolate can send a result message even when it exits, and it's the exit function is a future, and we can process that result in the main isolate and carry on with our events, and the isolate can die happily. So if we go back to our example, we still have our async and await keywords. We're still returning a future. But now this code will run in an isolate at this point here. We isolate spawn this function. So this is happening in the main thread, the main isolate. This code will happen in the spawned isolate. And our JSON parsing will happen in the isolate. Also, all the code in this example, again, it's native Dart, so receive port and isolate are built in to Dart. You just have to import the relevant package. To pass the JSON, we spawn the isolate. We wait for the first message, port first, and the JSON data. And the arguments that we need to spawn must match the function signature that we invoke. So we have here the read and pass JSON name of the function, and it must match this name, and the arguments here must match the arguments here. If we have more than one argument, we can wrap this in an array. And then the exit will send the result. When we exit, it will send back the result that he's waiting for over here, waiting for the JSON result. Isolates can be long running, so it's not just like go read from the network, return some JSON. It's you can spin an isolate up and let it live the whole life cycle of the app. For example, the use case would be multiple network requests, where we would send URLs and we would get back our JSONs. So we get our response JSON, and at some later point we want another URL, and we return back, so let's say, an image. How can I use this long life cycle of an isolate? How can I use it in my painter? So in my main isolate, my app spawns a painter isolate, produces images, which it will send to the main isolate. One image, another image, final image. There's obviously much, much more. There's hundreds and thousands happening at the same time, but just for understanding. And this is how I expect my isolate to behave. At some point, the user will either restart the painting or exit the app. So now we have isolates in our toolbox. How can I use them in my app to render images concurrently? In my app's main widget, this is not the full code, but let's say this is my main widget. It will display an image that was painted by the isolate, and it will wait for images in the receiving port, and then update the widget's UI. We all know set state updates the UI. This is going into the widget of the image, and inside this paint method is the isolate spawn. We'll see in the next slide. And it just waits for messages on the receive port, which is this receive port. So paint is called by the widget. Compute is a built-in function of Flutter. It's a wrapper function that spawns an isolate. It handles errors, and then it exits the isolate once it's finished. Paint isolated is the isolate entry point, and this is the main of the painter isolate. And notice that it's static. It must be static or global. These ones don't need to be, but this one has to be, because it's going to it's code that is not shared. It mustn't be in the painter class, because the class itself is not passed into the isolate. The code is shared because it's in the same isolate group, but this is the entry point, and it needs to know how to access it without having a painter object itself. All right, now that the painter can start painting, can start sending images to my main isolate. So we do some looping, we do some painting, where it does all the calculations, and then we want to send the image back to the main isolate, where it was waiting over here. So waiting for the images from his receive port, but in my painter isolate, it's on the send port. So my paint function does all the complex calculations and rendering of the rectangles and the pixels. At first, I tried to paint the rectangles using a canvas, which needs a picture recorder. These are classes from Flutter. I would then display the recorded picture, and then paint the read-only picture on top of the new canvas. So I would recycle the picture recorder, which produces a picture, and then I would repaint the picture on the canvas as if it was a mutable bitmap. Okay. So this code seems pretty normal, right? But if I try to use this code in an isolate, boom, trach. I don't know if you can see. UI actions are only available on root isolate. And the root isolate is another word for the main UI isolate. There's a lot of requests for the Flutter group to allow UI rendering not on the main thread. Okay, so now that the painter isolate sends the raw bytes, I have to now use raw bytes and byte buffers, not pictures and images that Flutter has. And I now need to send the raw bytes through the port, and then I need to convert it on the main thread, on the main isolate. I need to return it, to convert it to a Flutter image. So it's a little bit more expensive, but except for that, all the main heavy computations do happen on the side of the painter isolate. All the manually painting rectangles, not using Canvas, but using some third-party library that does its own imaging. All right, so now that we have the isolates, it works fine and dandy, and the user will feel much less jank. Also works for desktop. Let's maybe see a live demo. Can you see it? Ah, sure. Can you see it there on the TV? Yeah, okay. And you can press it while it's doing things. Interrupt it while it's processing. Do a new one. Stop it. Every time that I re-render, I kill the isolate and spawn a new one. And we can see that it's sending images pretty quickly. Okay. Okay, I said it works for desktop, works for Android, works for iOS. What happens when you try to run the app in a web browser? Boom, trach. Isolate not supported on Dot for web. Unfortunately, Dot is supposed to be, we theorize, we expect Dot to be cross-platform, but since Dot 2, the Dot web platform, you guys can't see here. Dot web platform no longer supports isolates, and it suggests that developers use web workers, which means more work for us as developers. We have to now handle also web workers, and everything else uses isolates. All right, so what have I learned? The Dot does support concurrency. It's not exactly out-of-the-box threading with async and waiting and all that. You have to use isolates, but they do help, especially with heavy I/O, heavy computations, and they're really not as complicated as you think. It's basically 2 or 3 step process. Spawn, have some function that is the entry point, and return some results. Thank you. Questions? The question is if it's not intended for drawing a Flutter UI and Canvas in the isolate.
Yeah, using
right.
Painter, for instance.
It is intended, but the implementation is not there. The implementation expects the UI to only be in the main isolate for now.
If I'm loading textures, so it's good. Texture files, that's fine.
If you're doing everything else except using the UI components and widgets and all that, everything else is fine in an isolate. Networks, files, whatever.
Right.
Yeah?
So there's no way to use like shared memory between the isolates, right?
There's no shared memory, no.
And if you want to switch to using like native code, perhaps like C library?
If we want to use native code,
Yeah.
like what?
Say you want to use like platform code like this.
Like channels and plugins and things like that. You can do that.
You still have to serialize the data? Or
Well, again, if it's in the same isolate group, they do get shared code. So you can do the channels and whatever. I think what it means by not sharing code is that once you've created your objects and loaded all your packages, it won't know about that stuff. But in the usual standard Flutter app, It's usually everything's in the same group, so code is shared. You can use your channels. You can use your plugins from Android, iOS.
Copy the bytes. Realize the bytes when you want to send.
You do that when you use channels anyway.
Right, so how libraries that work like on video and use heavy programming, how do they work?
Flutter itself is very capable of doing video. Especially it's using the skier library, everything's optimized for UI.
On the same isolate?
On the main isolate, you have to check how the renderer is doing it. The decoder, if it's using a hardware decoder, it's much less. The hardware decoder will definitely seem to use the GPU, but it will have to pass frames to the main isolate on the main thread. Also depends how you want to show the rendering. Depends which library you use as well. There's a third-party libraries that wrap various video codecs.
Still, as you say, they have to pass the bytes.
They still have to pass the bytes. But the big thing is, if you're doing the decoding in the main isolate, is it worth passing the bytes? I think so, yeah. Yeah.
So would you say it's like using services for Android? It's like something
That's what I said in the, it is like using services for Android. I said before it was like much more similar to an intent service. Because it's separate, there's no UI. It has its own code that it runs, and the way you talk to it is using intents, which are serialized, parcelable data.
This is like a long lifespan, no? If you just need a network request or a simple I/O.
Yeah, but if you have a simple network request, you don't just start a service.
Yeah.
You expect it to be long-lasting.
For this is the future and nothing alone enough, right?
It's usually enough. Usually the user won't feel the difference between async and await if it's a small network request. Let's say you're making some small request to your server and you get back a few kilobytes of data. The user usually won't feel it. You'll only start feeling it when it gets hundreds of megabytes of images and
Downloading files, you would use ISO.
yeah, use it for downloading files.
And then you can like imitate the async task background update, or like.
That's what I was doing. I was originally using async task, and I wanted what is the equivalent in Dart and Flutter. Yeah.
For updating stuff.
If you want to also, let's say, upload some file to the server, you would also use an isolate, which is like a service. But now in Android, you need, let's say, a foreground service to show that it's what progress it's uploading. So you would send the update to the main isolate, show the user.
And if you need to do like multiple web requests?
So the question is, if you need to do multiple web requests also, you have your running isolate, your network isolate, let's say. You pass it URLs, and you get back your bytes, let's say. Which could be images, JSON, whatever you know it is. Yeah. Okay, so the question is, if you want a service running in the background while the app is not displayed. Yeah, you would use an isolate, but unfortunately, I didn't check how to do that in Flutter yet. I haven't.
Is there a limit on the number of isolates running? Like
The limit of the number of isolates, just on how much memory you have, I suppose. You can spawn as many as you need. Let's say you really want to be wasteful and have a spawn for each network request or for each database query. But at some point, they will exit and they will get garbage collected. Okay.